Hi Ayush. Ayush, we are having clients like a big enterprises. They are having issue like new API integration which take 2 to 4 months. How you think? What is the reason and solution for this?
Hmm. So, Mohit, basically, why does any company, even with 50, 100 developers and a good tech team, take a long time to integrate APIs? For example, in case of fintech, um, new lender integration takes 2 to 4 months. This is a common story I have heard as I meet more and more people. So, what is the reason for this? Effectively, the reason is more effort. Number one, they are doing more effort, and second is more back and forth between the teams. Let's break this down further, the effort piece. Why is there more effort? More effort is probably because, firstly, integrating a new lender into the system or integrating this new API requires you to change many other parts of the system. Okay, so it has a cascading effect on rest of the system. That's number one problem. Hence, more work. Second is that there is probably a lot of back and forth happening between the two teams integrating APIs between each other. And the third thing is that because of these two things together, that there's a lot of back and forth, surprises, and so much more quantum of work to do. There's a lot of development, there's a lot of testing, and lot of iterations of these cycles of development, testing, deployment, and you keep discovering surprises, and then you have to go through a whole new iteration again. So more work introduces chances of more mistakes, and as well, the back and forth between the team also introduces delays. So why is this happening, right? So now let us break down into the main reasons, and I see four main reasons that why do teams go through this. The first reason is that basically you have what would I say, lack of universal interfaces for a particular use case. For example, if we talk of lending, so this means that you do not as a company have a universal lending interface. Your entire system is not made as per a universal lending interface. Hence, every new lender requires you to do a lot of work, which could mean changing your database schemas. It could mean writing new kinds of transformations and handlings. It could mean many other changes you bring in your system, and hence bringing one change may break another feature of your product, right? So the first thing is lack of universal interfaces, and which means that there are cascading effects. Then the second reason is that you have a coupled architecture of a system. You're probably running a monolith, an LOS or an LMS. Maybe many types things are combined in legacy systems. So the monoliths effectively require that even a single change in your product, in your even a single API, requires you to test the entire product. Hence, there is more effort of testing for the testing team, QA team. Then this whole iteration goes through to the development UAT, where you test in the UAT. Now you find that this particular new API change broke some other feature. Then again coming back to the whole cycle. That's the second reason, is a coupled architecture. Third reason is basically back and forth between the teams coming from lack of schema-driven development. So you do not have clearly defined request and response schemas. That means the systems exchanging data between each other do not have very clear and very tight contracts between each other. This means that you can surprise each other, right? So teams often surprise each other, and hence the back and forth keeps going on. And lo behold, a new surprise, a whole new cycle of development and testing again goes through, right? That's the third reason. Fourth reason why teams are slow in this whole journey is because you do not have frameworks which save you from boilerplate code. Correct? So teams have to write a lot of boilerplate code to get things moving, to integrate any new API, to cache a response, to retry, to refresh your token. Since you have to write more boilerplate, it increases the chances of mistakes again and reduces the efficiency of your developer. So all of these reasons combined together make things slow. So what is the solution for teams, right? The solution is again four-pronged. These four problems need to be solved. The first level, we should ideally, and which we did with one of our clients, Pine Labs, right? They used to take 2 months to integrate a new API. They've been able to reduce it to 2 weeks. So what are the steps you take for the same? Number one, you basically define a universal API schema for any particular use case. For example, loan origination system, loan management system, whichever interfaces you're integrating with a lender, right? So any lender API should have a universal interfaces of all use cases. For example, getting a loan offer, right? Or basically creating a new account, or basically updating the ledger and records between each other. So what if you as a company and as an organization have a universal schema, APIs, and a universal implementation? So no matter how many lenders you are connected to, your code is running only on one schema of the API. Request response and database schema is also the same for everybody. So now what you need to do, when a new lender comes, you just need to write a wrapper where you integrate that lender and transform the request and response into a universal format. So hence this new lender does not touch the rest of your system. That's the step number one, is universal schemas. Step number two that you should follow is decoupled architecture, right? So monoliths, basically making one change in monolith, releasing it requires testing everything all together. So let's break the monolith and deploy microservices based architecture. So that, and maybe have a different lender integration microservice, right? This microservice and a different lending wrapper microservice. The wrapper microservice simply integrates with lender APIs, transforms request responses, returns response in a universal format. Then the lender integration is handling only the universal format from there on. So these could be two separate microservices. So whenever a new lender API has come up, you just need to make change in one microservice. It is also possible you could go further ahead, right? If you are actually in some other business where you have to integrate lots of APIs, so in that case, you could even spin up separate microservices for different integrations, wherein you're just not touching anything else. Hence, that reduces the whole development cycle, right? Less things to test, less things to deploy, less things to develop. So second solution is basically a decoupled architecture, a microservice and event-driven architecture. Then the third thing which we discussed was the data exchange issues, where we get surprised, right? Because of poorly defined contracts, we don't know what may come, what may go out, and it introduces bugs in the systems of both the parties. So hence, what we need to do is all development teams, no matter which industry you are in, define your API contract very strictly and ensure that whatever you promise as a tech team from your service, that this is my request I accept, this is the kind of success responses I will give, these are the kind of failure responses I will give, and this is the schema of every possible response that I will give. Honor that, right? And make sure that you do not send any extra data or any wrong data or any less data than what you have promised to your consumer. Okay? And at the same time, when you integrate with another API, you are not accepting any extra data, not accepting any less data, or not accepting any wrong data as an input from that API. So you are protecting rest of your business logic from a wrong data format. Okay? So schema-driven development prevents surprises between the team. It prevents so many bugs because you have a strong guardrail to protect the sanctity of data exchange between your different parties, your microservices, and external parties as well. And this is a guardrail within Godspeed called schema-driven development, our first guardrail, if you have seen our videos. So now coming to the last point, which is about lot of boilerplate, right? So when we are calling external APIs, often we are caching the response, we are doing retries, token refresh, so on and so forth. So there, developer writes a lot of boilerplate code, okay, and that code is also coupled with the kind of libraries you use. All right. So this basically increases the effort from every developer, and especially if you have young developers, it increases the complexity for them, and hence it can become a problem for you. Because the more work you have to do, the more chances of mistakes. Hence, avoid boilerplate. That's the fourth part of the solution. Develop your own frameworks, right? Many teams do it basically. We develop our own frameworks to save us from boilerplate, from doing repeat work, mundane work over and over again. And this boilerplate also increases the effort of maintenance in your system. Tomorrow you want to change something, you have to change it in 100 places if you have 100 APIs integrated, right? So do not write boilerplate code. Which is the same thing we are also trying to solve through the second guardrail of Godspeed, is configure versus code. So a lot of this behavior which is not business logic can be configured, like lazy loading, token refresh, retries, custom telemetry can be configured, and it can be expressed in higher abstractions like YAML or as annotations within your native language API of Java or TypeScript. So doing these things basically like decorators or annotations helps you save the boilerplate. This is what we are also solving via Godspeed. So yeah, these are the 4 solutions for teams who want to reduce their lending integration time from 2 months or 4 months to 2 weeks. And this is something we achieved with one of our leading clients called Pine Labs, an amazing fintech company from India. And we even have a video of them talking about it. Do check that out. I hope this helps. Thank you very much.